So if we look at this equation again, we can see that the copper is an ion. It's going to go from +2, and then it's going to become a 0 because it's alone and it isn't shown as charged. So if you have a +2 going to a 0, you are going down in charge. So the copper is reduced. Likewise, whenever you have a reduction, you have an oxidation. So let's look at the iron here. We have iron, which is charge 0 because it's alone and there's no charge written on it. It's not an ion yet. It's going to end up losing 2 electrons to become +2. So its charge went up. So it was oxidized. So looking at this equation, you can see that the iron loses custody. The iron is oxidized. The copper is reduced. So let's look at this equation again. We need to write those half reactions. So we identified that the copper is going to be reduced. So to write that half reaction, for it to go from a +2 to a 0, it had to have gained electrons. That's really important. So likewise, for the charge to go up, it has to have lost electrons. And that's also very important. So since we have copper being reduced, it means we're going to have to write that copper will gain 2 electrons. We need to show this on the reactant side to form copper 0. So this is our reduction side, and this is going to be extremely important when we do batteries. Likewise, the oxidized species is iron. So we're going to write down that iron, it had to have lost 2 electrons because electrons are negative. Don't forget, are negative. Very important. This always confuses students. So we've got iron. It's going to lose 2 electrons to make itself a +2. We have to show that it lost 2 electrons. So in a battery, what we have is something losing electrons and something gaining electrons, and then we get a flow of electricity.